Chapter 14, Ocean Water and Ocean Life. Composition of seawater. Seawater consists of about 3.5% by weight of dissolved minerals. Salinity is the total amount of solid material dissolved in water, typically expressed in parts per thousand, which is 0 over 2 zeros. The average salinity is 35 parts per thousand. The major constituent is sodium chloride. Okay. So here we have, let's say if we have 1,000 grams, or basically 965 grams of water, so we take 1,000 grams of ocean water, 35 grams, or 35 parts of 1,000 is going to be the salts, where 965 grams or parts will be the water. Okay. Of those 35 parts per thousand, over half of it be chloride ions, and a third of it be sodium ions. So here you get your sodium chloride or your salt, right? And then you'll have about 8% of silicates, dissolved silicates, 4% dissolved magnesium, 1.2% of calcium, 1% potassium, and then some minor constituents. Sources of these sea salts. Well, chemical weathering of rocks and outgassing. These are gases from volcanic eruptions. Processes that affect seawater salinity. Well, variations in salinity are a consequence of changes in the water content of the solution. Okay. So, processes that decrease salinity, so add water, are precipitation or rainfall, runoff from land, melting icebergs, and sea ice melting. The processes that increase salinity or remove water are evaporation and the formation of sea ice. Okay, surface salinity in the open ocean ranges from 33 parts per thousand to 38 parts per thousand. Surface water temperature. The ocean temperature, the surface water temperature varies with the amount of solar radiation received, energy from the sun. Lower surface temperatures are found in the high latitude regions, and higher temperatures are found in the low latitude regions. The temperatures vary with depth into the ocean. So in the low latitudes, there's a higher temperature at the surface and rapidly decrease in temperature as you go deeper. That's called a thermocline. Okay. At the high altitudes, the surface is cooler, but there's no rapid change in temperature with depth. Okay. So in the low latitudes, as you go deeper into the ocean, okay, we start with warm waters, 20 degrees Celsius, about 70 degrees. So 24, let's just say mid-70s, okay? The surface water temperature as you go deeper into the ocean, now this scales meters, you'll have a rapid drop in temperature until you get to about 1,000 meters, where it's about as cold as it's going to get. In the high latitudes, where temperature is already only about 2 degrees Celsius, which is a little bit over freezing, there's no real thermocline. The temperature is going to remain low. The ocean temperature over time. The unique thermal properties of seawater make it resistant to temperature changes. Global warming could eventually influence ocean water temperatures. So variation in the ocean's surface temperature and salinity with latitude. Okay, so this x-axis we have latitudes from 0 for the equator and going southwards and going northwards. We've got temperature in degrees Celsius with the zero is here. And the salinity scales over on this axis over here, 32 parts per thousand up to 38 parts per thousand. Okay? So here we have our temperature graph. The ocean water is warmest near 0 degrees latitude, and during the high latitudes, the surface temperature is lowest. Now the salinity is also lower where the temperatures are lower, and higher where the temperatures are higher, with the exception of near the equator. Density is mass per unit volume, so how heavy something is for its size. This determines the water's vertical position in the ocean column. Factors affecting seawater density are its salinity and temperature. Temperature giving the greatest influence. So variations with depth. In the low latitudes, there's low density at the surface. Density increases rapidly with depth. It's a pycnocline because of colder water. Okay, colder water is denser. High latitudes, there's a high density cold water at the surface, and there's very little change with depth. So in the low latitudes, the pycnocline, the density of the water increases rapidly as the water cools as you go deeper, until it gets as dense as it's going to get. The high latitudes, the water is already cold at the surface, so it's going to remain at the same density throughout the column. Okay, so in the ocean water is layers itself, and it's layering itself according to density. There's a 3-layer structure. There's a surface mix zone, which this water is sun-warmed. It's a zone of mixing from the surface to deeper, and it's fairly shallow, about 300 meters. The transition zone is the zone between the surface layer and the deep zone. This is where the thermocline or pycnocline is, the change portion of the thermocline and the pycnocline. And below that is the deep zone. The sunlight never reaches this zone. The temperatures are just a few degrees above freezing, and it's constant high density water. So here's a diagram. We have our surface mixing zone, about 2% of the ocean column. And then we have our transition zone, which is another 18%. And 80% of the water is in the deep zone. Ocean life. The marine environment is inhabited by a wide variety of organisms. Most organisms live within the sunlit surface waters because of photosynthesis. They need to make energy out of that sunlight. Now, classification of marine organisms, we have plankton. Those are these microscopic floaters, and algae, the phytoplankton, that do the photosynthesis. Okay, and then the zooplankton are the more animal-like plankton and bacteria, and all the plankton compose most of Earth's biomass. Then we have nekton. Nekton are all animals capable of moving independently of the ocean currents. Okay, the plankton just float around. The nekton, they have their own mobility. They're unable to move throughout the breadth of the ocean. Okay, so, and also benthos, or benthic dwellers, or the bottom dwellers. There's a lot of species that exist on the shallow coastal floor. Most live in perpetual darkness in deep water. Several factors are used to divide the ocean into distinct marine life zones. 1, the availability of light. The photic zone, or the light zone, is the upper part of the ocean. It is sunlit. Okay? The euphotic zone is very near the surface, where the light is the strongest. Okay? Also, the aphotic zone is the zone without light. So it's a deep ocean. There's no sunlight. Okay, another factor to categorize marine life zones is distance from shore. The intertidal zone is the area where land and ocean meet and overlap. The neritic zone, which is a seaward from the low tide line and the continental shelf out to the shelf break. And then the oceanic zone, the zone beyond the continental shelf. The third part of our classification before we finally get to a diagram is water depth. The pelagic zone is open ocean of any depth. The benthic zone includes any sea bottom surface. The abyssal zone is a subdivision of the benthic zone. It's deep, extremely high pressure water, and low temperatures. The abyssal zone has no sunlight, sparse life. Food sources include decaying particles from above, large fragments falling, and hydrothermal vents. So here's our diagram of all three of these things all together. So the oceanic zone is the whole range of the ocean. Okay. Let's see. So from the continental shelf, we'll say from high tide to low tide is our intertidal zone. Okay. Then our neritic zone is from low tide out to the shelf break. Then we have our oceanic zone. Okay. Here's our benthic zone. It's the seafloor. The abyssal plain area, the abyssal plain, the pelagic zone. The aphotic zone is all below where there's no sunlight. The aphotic zone is the region with the sunlight. Euphotic is the very top portion of that photic zone. Ocean productivity. Related to primary productivity is the amount of carbon fixed by organisms throughout the synthesis of organic matter. Sources of energy for this are photosynthesis from solar radiation and chemosynthesis, chemical reactions. This is influenced by the availability of nutrients and the amount of solar radiation. Most abundant marine life exists where there is ample nutrients and good sunlight. Okay, in polar oceans, Because of nutrients rising from deep water, high latitude surface waters have a high nutrient concentrations, but they have low solar energy, which limits photosynthetic productivity. And in tropical zones, productivity is very low in the open ocean. The thermocline eliminates the supply of nutrients from deep waters below, but there's plenty of sunshine. Okay, so in a polar ocean, okay, here we're going to see look at productivity in the polar ocean. And we find first the diatoms, which are going to be the food for the zooplankton. Okay, the mass of diatoms in the winter there's be very little, but as the seasons change in the spring, there's going to be a peak of diatom mass in the polar ocean around May. And that's when the zooplankton really start to thrive, and their peak is going to be towards the summer. Okay. Now in northern temperate regions, the productivity in general is going to be higher in the spring, with a secondary peak in the fall. The North Polar height of productivity is in that summer zone, and the tropical just kind of remains low year-round. Productivity in temperate oceans. In the winter is low productivity, days are short, and the sun angle is low. In the spring, there's a spring bloom of phytoplankton, which is quickly depleted, and productivity is limited. In the summer, the strong thermocline develops, so surface nutrients are not replaced from below. The phytoplankton population remains relatively low. In the fall, the thermocline breaks down and nutrients return to the surface. Short-lived fall bloom of phytoplankton. The highest overall productivity occurs in temperate regions. Okay, so as temperate regions, these are the north of the tropics, but before you get to the Arctic. Okay, so we have our phytoplankton bloom in the spring, and then we have a secondary bump in the fall, and the thermocline breaks down again. The zooplankton follow the phytoplankton, so their peak is just after the phytoplankton's peaks. Okay, the most sunshine is in the summer, least in the winter, and the amount of nutrients available is higher in the winter and in the fall winter again. Oceanic feeding relationships. Main ocean producers are marine algae, plants, bacteria, and bacteria-like archaea. Only a small percentage of energy taken at any level is passed on to the next. The trophic levels. Chemical energy stored in the mass of the ocean's algae is transferred to the animal community mostly through feeding. Each feeding stage is called a trophic level. Transfer energy between trophic levels is very inefficient, only about 2%. Okay? So, with solar radiation, let's say the sun is giving us 500,000 units of radiant energy. Okay? The phytoplankton, they convert only 2% of that into energy, so there's 10,000 units of energy. The zooplankton eat the phytoplankton and take only 2% of the 10,000, which is 1,000 units of energy. And then the fish will eat the zooplankton, and now only 100 units are available. Big fish eats the little fish, 10 units become available at this trophic level. And then when we eat that big fish, we're down to only 1 unit. It originally started at over 500,000 units of energy. Not very efficient, but it works. Food chains and food webs. Food chain is a sequence of organisms through which energy is transferred. A food web involves feeding on a number of different animals. Animals that feed through a food web rather than a food chain are more likely to survive. For example, we have a copepod that only eats diatoms. The Newfound herring only eats this Calanus copepod. Okay? So if something should happen to the diatoms or happen to the Calanus copepod, the Newfoundland herring won't have anything to eat. Case here, we have the northern sea herring, which will eat mollusk larvae, arrowworms, sand eels, copepods, tunicates, amphipods. Okay? And all these creatures, they eat diatoms. So as long as one part of the food web is being very productive that year, the North Sea herring will stay abundant. End of that chapter.